Raj talked about data for good, and I'll talk about that a little bit. Making it a better world. So what does it mean making the world better via predictive analytics? And so I think that's a little bit more detailed than what Raj is talking about. So there's a couple of key things here. So predictive analytics, and what does it mean even to have a better world? So I want to drill into that. No? There we go. So if we think about data, and Raj talked about a lot of different types of data. So I'm going to start with a very simple example. I'm going to start with a chocolate bar. So if we sell chocolate bars, data, which Raj mentioned probably at least 15 times, raw data is just the sale of a chocolate bar. So I work in a store and I sold a chocolate bar at 4 o'clock this afternoon, and I also sold the chocolate bar at 10 o'clock this morning. That's data. And we can think about it as just going up a little level into what is information. And so a simple example of that would be we sold 82 chocolate bars last month. So that's some information. You can do some things with that, but not a lot. Going up a level, you can think about knowledge. So knowledge could be things like trend analysis. So you can take a look at over the last year, we've been increasing our sales of chocolate bars by 20% a month. So that's some knowledge. But in data science, we don't want knowledge. We want to have some predictive insights, some actionable insight. And so as we think about what is actionable insight in the chocolate bar example, it would be that we understand and have looked at patterns of how people buy chocolate bars. And we see that baskets, when people buy chocolate bars, they also buy peanut butter. So maybe there'd be a good product that we should proactively create, which combines peanut butter and chocolate bars. And then we could proactively think about doing that based on the data we have. So obviously in that example, somebody's already done that because there's Reese's peanut butter cups that have that concept. And I talked about that for a couple of reasons. So what we do in data science, oftentimes you can do with other techniques. It just might take a long time, lots of resources or other ways. And it might take a lot of trial and error. So in data science, we try to simplify the process, make the process much more promising in terms of what are the actionable and useful insights. But that's how we really think about it. So what actions can we suggest that would be good to change the future, as opposed to looking back in time and thinking about how that worked? Oh, we're going to have to fix this. So if we think about data science, one of the things to highlight, Raj talked about all the good things that could be done, which maybe not surprisingly has been borne out in industry hiring, which is to say data science is one of the top fields from a hiring perspective. So you can look at this as Glassdoor. If you can't kind of look at the slide in detail, pretty much every year it's like the #1 job, #1, #2 job. It's stated in a lot of different ways in terms of growth and everything else. But the key is our skills, data science skills, are needed in lots of different scenarios. So now I want to go through some examples in the real world. Can we go to the next slide? That's much faster. So here's, I'm going to go through kind of a couple different examples and give you a little bit of feel for what they are. So the first one I want to talk about is outbreak analytics. So outbreak analytics is what will be the discussion tomorrow morning. It's where data scientists work to try to understand infectious disease and how they spread and kind of the patterns of how they spread. So, I guess unfortunately at this point, something like this is maybe more common than people would have thought about 2 years ago. So this is about COVID and different trends, but also about different predictions about the future. And so I don't want to talk about too much about this because tomorrow morning, you're going to hear a lot about it. Can we go to the next slide? Here we go. So the next one I want to talk about is climate analytics. And what I mean by climate analytics, everybody kind of knows about climate change. and everybody kind of can understand and think about the ramifications of that. So how does data science fit with this field? And so, one example that we can kind of see on this slide, and people have heard, and there was, all the major world leaders were recently together to talk about this. And so you kind of hear a lot about the Paris Accord, 1.5 degrees versus 2.5 degrees. So that's data science being used to understand the impact of climate change on the world. And what we're trying to understand is predict, based on what we currently know in terms of the environment and what we do to the environment, what will that do in terms of temperature change? But more importantly than just temperature change, then we predict what it will do to different aspects of the world, right? So the waters rise, and so you build a whole predictive model about what will happen in the future. So that's the key around climate change, is being able to predict the future, not just looking at the past. So if it was just data analysis, we would say that we've taken a look at the temperature over the last 50 years, and we can see it's increased a little bit. But that's not actionable insight. And so what we want to do is we want to have a situation where we can have actionable insight, which is if it rises by another 1.5 degrees, here's the impact in the world. If it rises by 2.5 degrees, here's the impact of the world, and things like that. So that's what climate analytics is. Go to the next slide. So health analytics. Lots of different scenarios of how this can be used. Raj talked about a couple. So for example, one of the things he talked about is stability and being able to understand and predict who might be unstable. Actually, even on your iPhone, there's software that's being kind of created now and used to help understand people at risk for falling. So again, think about that. It's predicting the future to try to make the future better than it would be if without that prediction. So if we can predict that you're highly likely to fall, then there's things that we can do as a society or as your doctor to give you some stabilization around that. So that's one example, but there's lots of other examples. So this is kind of what I just talked about here, right? Predicting patients for special services. You can also take a look at, historically, we've given lots of different treatments, and we can understand which treatments work better in different scenarios, or which combination of treatments work better. So that's a different example of trying to look at data, whether it be patient data, the analytics behind that, whether it be clinical data, and combining all that to predict the future. Another one that I'll probably discuss a little bit later could be, for example, predicting if you have cancer or not. So we'll kind of get into that one in a couple of slides. So basically, this whole field is around, again, it's not just analyzing the data, but it's making a prediction to understand, based on all this data we have, how might that be influenced and useful in the future. Go to the next slide. So this is what Raj talked about, data for good. You can think about everything I've just talked about up until now, and even a few slides after this, is all about data for good. So there's a whole field that kind of talks about data for good, but I like to focus on the different actual uses of data rather than this umbrella for data for good. So if we go to the next slide, you can see that for public administration, different roles within government. So the slide here talks about anti-corruption, but there's lots of other places in government. Raj talked about trying to predict development zones. So, houses, for example, where if they go down in value some more, it doesn't just impact that one house, but it impacts an entire neighborhood. That's an example of government analytics and how that can be used. If you can make that prediction, you can try to proactively stop that from happening. You can think about that. This whole concept could be linked to cybercrime and trying to predict where crimes might be occurring from that perspective. Go to the next slide. So sports analytics. So if you know sports, if you follow sports, pretty much any sport that you either play, or certainly if you watch at a professional level, has been impacted by analytics. And this is a field that's growing month by month, year to year, both from a financial perspective and an impact on the actual sport. And that's true pretty pervasively. But there's still areas where it's still very nascent and up and coming. So for example, how do you price the ticket of a sporting event? And what's the best way to do that? And so that's not really data for public good. It's data for good for certain people. And so when we think about data for good, or kind of how to make the world a better place, not all projects will make everybody better. So when you're thinking about it more from a business context or a sports context, it's how do I get better than somebody else, perhaps, is one way to think about it. We go to the next slide. So business analytics, this is definitely driving most of the jobs. And quite honestly, even most of the press around how it's being used. So there's lots of different examples. I gave an example earlier about cookies and chocolate bars, but you can also talk about just analyzing customer behavior. So taking a look at different sales trends and what people are buying or what they're not buying. You can think about trying to predict fraud. So I used to work at a bank. So banks use credit cards or service credit cards. There's lots of prediction about, is this a fraudulent transaction or is it not a transaction that's fraudulent? We can try to predict future customer services, future customer products. Raj mentioned inventory management. So it's not the most interesting part of data science, but it's certainly used a lot. If you go to the next slide, you'll see something that's pretty common. Hello, there. So this is something you've already seen, and it's just same thing as Netflix, right? So when you're watching Netflix and you're just lazily there and you're done a show, maybe you haven't done it, but I've certainly just been on my couch and didn't want to do anything. So this is using data science to try to understand what we're going to predict that you would like to use next. So that's really the goal and the focus of this. Again, so this isn't to make the world a better place, but it could be to make your world a better place because it's suggesting either something to read. You can see that I'm into data science, these suggestions, or something to watch. So again, it's highly structured in terms of what that is. So if we go to the next slide, I think I kind of want to think about things from a different perspective. So college alumni, and again, you can think about this as how do we take different groups of people and create different persona. So I thought I would kind of use this as an example for alumni analytics. So at a very simple level, you can think of 3 levels of engagement. And this is a characterization of a group of people. And so we would cluster people into, maybe alumni that are just a little bit engaged, or alumni that are pretty much engaged, or really strongly engaged. And obviously, there's lots of different dimensions to that. And we can think about that across multiple different ways. But that's really a way to think about using analytics to think about how we should be treating people, whether it's about alumni, whether it's about customers at a hotel. It's the same idea. So a customer at a hotel, we want to think about it in a certain way. How do we treat people that come here frequently versus people that don't come here frequently? How do we treat business travelers versus people that are on vacation? Next slide. So I could keep going, but I thought, how do I end all this? Because I didn't really know which topic to end. And I thought everybody loves dogs. Well, not everybody. I love dogs. So you can even have doggy analytics. So there really is a discussion about how to think about analytics when you train dogs, right? So what are they learning? What are they not learning? How do you reinforce different behaviors? And make predictions about what training methods would be better for different dogs. So pretty much anywhere where you can imagine that we can collect some information and then make a prediction about the future is where data science can be used. And the key is that we're going to make a prediction, and we're going to make a prediction that will be helpful and useful, not just interesting. So that, in a nutshell, is what data science is. We take a look at the next slide, we'll kind of start to drill into deep learning. So everything I talked about to this point was different industries or uses. Deep learning is different because it can be used across many different domains or areas. But it's a pretty pervasive way to think about what is data science. So deep learning can be used across self-driving cars. So most people by now have heard about lots of different versions of self-driving cars that aren't quite totally self-driving yet, even though Tesla has something that pretty much calls self-driving cars. But it's definitely getting closer. And so you can think about what's happening here is we're making predictions that this is a person and this is a car. And this self-driving car is trying to make a prediction about where best to go is the best way to think about deep learning. But it's not just for driving cars. Deep learning can also be used in a number of other ways. So for example, Hey Google or Alexa is using deep learning to understand what you're talking about. And cancer detection. So I'll just kind of give that one another one, which is it can learn. What I mean by it, the data science machine learning algorithm can look at lots of different examples of blotches on skin and know which ones are cancerous and which ones are not. And so today you can use an algorithm that looks at your skin and can make predictions that are as good or better than doctors because it looks at that. Go to the next slide. So this is a little slide that talks about how effective deep learning is for understanding speech. So you can look at from roughly 2001 to roughly 2013, there really wasn't a huge change. People could be much better than computers. And then deep learning was introduced over like a 2 or 3 year period, and very quickly became as good as humans. And now data science machine learning algorithms actually are slightly better than humans in understanding it. So Alexa or Hey Google, it's really good. And it's better than if you just listen yourself. Next slide. So when we talk about like Hey Google or Alexa and natural language processing and text mining, I wanted to give you a little simple example of how sometimes it can be challenging. Give you a little feel for what like data science challenges are. So here's a little sentence. I saw the man on a hill with a telescope. It's a pretty simple sentence. Not that complicated. You can go to the next slide. So here's one interpretation of what it is. I saw the man. The man was on a hill, and I was using a telescope to see the man. So that's the first picture that's outlined. If you go to the next one, the exact same words, just different punctuation, you can see that I saw the man was on the hill, and the hill had a telescope, which is kind of the other picture that was highlighted. So the same words mean two different things based on the context and punctuation. And so that's some of the challenges as people work on different aspects of data science, not from a pure predictive numbers perspective, but from text mining and natural language processing perspective, which is what a lot of deep learning does, gives you a feel for some of the challenges that need to be overcome. You go to the next slide. Let's go on. So what are the key components of doing data science? This is a pretty common Venn diagram to try to explain it. There's probably 20 other Venn diagrams that also try to explain it. So there's not one consistent definition of what is data science or what are the skills you need. But I thought since this is probably the most common one, I would start from here. So part of data science is you need some computer science skills, such as programming in R or Python or something like that, understanding how algorithms work. You need some math and statistics. So when you're doing data science, you have to understand probability because your model is never going to be 100% correct. So you need to understand what does it mean for the algorithm to be likely to be correct? What does that mean? And then you need some domain knowledge, because if you just have the computer science knowledge and the math and stats knowledge, and you can't know how to apply it, then you probably won't be creating actionable insight. You just be creating insight that either is obvious or not useful. And so you need this domain knowledge. And so kind of at the core in the middle is what data science is. And at the iSchool, as Raj talked about earlier, we kind of think about it as human-centered data science. So we're not really focused on the extreme of building the next best machine learning algorithm. That would be more of a computer science department. We're not focused on deep math and statistical skills. We're definitely focused on how to apply data science in many, many different human-centered contexts. All the ones that Rod was talking about and that I talked about. Next slide. So when we think about a data science project, we can think about a life cycle of kind of how we work on a data science project. And I thought this would be a good way to help you have, again, just a little bit of an understanding of what data science is. So we start almost always with data understanding and business understanding. So we need to understand the business context of all this data we've collected. What is the problem we're trying to solve? What are we working on? What kind of prediction would be useful? What kind of prediction wouldn't be useful? What data is available? So that's about data understanding. What data is available? How valid is the data? How clean is the data? How much data do we have? What type of attributes do we have? How can we think about different ways of collecting data from maybe different sources and combine them together? And that combining it together, that's the data preparation phase. So the data preparation is what I like to call data munging. So it's kind of, in the end, a lot of like maybe programming to get data into a common format. And then we do modeling. So this is actually building a predictive model. So everything that I and Raj are talking about, really, maybe you're focused more on the modeling part of the data science, but there's definitely more. And then once you build a model, you have to understand how good it is. That's what evaluation is. And then once you evaluated it, you still haven't gotten anything useful. You have to deploy it. And deploying your results might be very different based on the context. So if you're Netflix, deploying a model means letting people get a prediction about what to watch next. If you're a marketing organization, it might be how to do a certain campaign. So you're only going to have it used once. And if you're a researcher, deploying it might be a publication in the paper, for example. So these are the different ways you can think about it, but all these steps are done to do a data science project. And this is done iteratively. So it's not like we understand the business, we understand the data, then we prep the data, then we build a model, we evaluate, we deploy, and we're done. Data science almost never works that way. You think about this as like, we understand a little bit of the business, we understand a little bit of the data, we have a model that's not so bad, and maybe we deploy it, but maybe we don't. But what do we learn from that? And then we do it all again. And then we do it all again. And then you do it all again, and again, and again. And eventually you start to learn collectively, and the model starts to learn about what's useful. And maybe halfway through, you go like, oh, there's this other data that we never thought would be useful, but if we pull that in, maybe that can improve the model. So that's the spirit of how data science really kind of works. Next slide. Oh yeah, so this kind of talks about it from a skills perspective, and you can kind of keep hitting next because it's going to kind of keep going. So we start by learning the application domain, and then we communicate with users. So these are all kind of the different skills you can think about through that life cycle. And then we kind of start to see the big picture, which is kind of understand how and what predictions might be interesting. We have to think about how we're representing the data. We have to transform the data. So you can think about these, there's different skills. Quality control is something really interesting. How do you know your model's correct? How do you know your prediction isn't just the result of some error somebody typed when they were writing some algorithm sometime? How do you know that your data doesn't have some bad structure to it, bad data? Maybe actually just it's humans, so maybe someone typed something in wrong. How do you know it's correct? You don't really know. In the end, you have to present it in an intuitive way to whoever's going to use that algorithm, whoever's going to use that prediction. So you need to present your prediction in a way that's intuitive to somebody that doesn't know data science. And that's what visualization and presentation is about. And in fact, in 20 minutes, Professor Hemsley, who's in the back of the room, will be talking a lot more on visualization and presentation and things like that. So we'll kind of skip that. So if we go to the next slide. So I wanted to talk for just maybe 2 minutes on kind of ethics and what does it mean, because we talked about human and data science and human-centered data science, but I wanted to kind of give you just a little touch of a feel about what it is. tomorrow, I don't know, right before lunch or right after lunch, I forgot which, we'll talk about some more about ethics. So if we go to the next slide, we'll kind of take a look. So first of all, there's lots of examples of models gone wrong. I won't highlight these. All I'll say is that these companies did not set out to get headlines in big newspapers that were not very complimentary. But things can go wrong. And if you're not careful about how you're using data science, it's easy to fall into this trap. These are obviously intelligent companies with lots of very smart data scientists. So if we go to the next page, these risks are pretty well understood by senior leaders in industry. So I've highlighted here, if you're looking, they're kind of grayed out in the background, all the issues that are related to kind of ethics and situational challenges in using machine learning and data science. And you can see out of all the different concerns of industry leaders, about half of them are related around ethics. This is from Deloitte, in case you're curious. Next slide. So I wanted just to end this by, as we're thinking about ethics, I wanted to give you a little bit of view of why it's hard. So fairness is a great concept. Every data scientist that I know has integrity. Doesn't mean everyone does, but all the ones I do has integrity. So they want to do what's right. They want to do what's fair. They want to build a model that's fair. Sounds simple, right? Let's build a fair model. So if we go to the next slide, we'll see that maybe it's not so simple. Because let's take a kind of the example of giving out a loan, right? So I used to work at a bank, so I know all about giving out loans. So if we want to give out loans, the question is, what's fair? What's the right way to decide who gets a loan? So one scenario, top bullet here, is ensure that we make loans available at the same rate for two different subgroups. So people that have blue hats and people that have white hats. So for whatever reason, you have a blue hat or a white hat, and we're going to be fair because we're going to say, the same percentage of blue hats and white hats gets loans. That's one definition of fair. And a lot of people would argue that's the right way to do it. Another definition is we're just going to focus on each person individually and make sure that we're going to kind of maximize who gets a loan based on their ability to pay back. And we're going to take into account what color hat there is, because that's part of being able to pay back the loan. And so that's fair is if you can get the loan and repay it, we're going to give you the loan. And if you can't, then we're not. So that's the definition of fair. Another definition of fair is we're going to maximize and look at who can repay the loan, but we're going to ignore what color your hat is because that's not appropriate to look at the color of your hat. And obviously we can change color of your hat for lots of other characteristics. So there was 3 different definitions of fair, and whichever one you say is right, I can come up with a counterexample to show that a different one is correct. So when we think about trying to do the right thing in data science or trying to do what's fair and unbiased, just remember that it's not just a data scientist needs to do the right thing. Sometimes it's not clear what the right thing is. And I've had this entire conversation without ever talking about really what data science should do. It's more just conceptually what should we be trying to do. And there are other ones. I just did the top 3 that are kind of intuitive to people, but I could define 2 or 3 other definitions of fair as well. So you need to kind of think about what does it mean to be fair? What are the implications? Is it okay to use attributes? Is it not okay to use attributes? What's the implication of using the attribute? What's the implication of not using the attribute? Sometimes it's legal, sometimes it's not. So there's lots of different ways to think about that. You can think about groups. What level of groups make sense? Is it good to create these groups by hats, or should we ignore that there's groups by hat? The second scenario. So what might seem to be simple is not so simple. And I think with that, I'll turn it over if there's any questions.
Yes. So there's one from Patricia. She asked, what really does health analytics entail? And then as a follow-up, what knowledge domain would you look for, would you focus on as a potential student? So if you want to tackle the health analytics one, then I can ask that second one after.
Yeah, so health analytics, so first of all, health analytics is a huge field. We can think of health analytics as everything from the outbreak analytics that I talked about at the beginning, so trying to understand infectious disease and how it spreads. You can think about health analytics as being used in different deep learning applications like I talk about to detect skin cancer. You can think of health analytics in terms of looking at patient care, seeing outcomes for those patient care, having lots of patient records, and then trying to understand what type of patient care works best for what type of patient based on their condition. So those are, I guess, 3 or 4 different examples that I just rattled off. And they're all I would put under the umbrella of health analytics. So, and the second part was kind of what background would be helpful or something like that.
Yeah, what knowledge domain would you focus on as a potential student?
So I think, it's important to have enough knowledge to know how it can be useful. But I don't think you don't have to be like a doctor, a medical doctor, to also be somebody that can contribute to health analytics. So I think the best way to think about it is you have to have passion and interest in that domain, but you can learn by talking to the domain experts as well.
And then there was another question about a couple of specific languages. So it was saying when it comes to data visualization, is Tableau the preferred choice over Power BI?
So let me think about the shortest way to answer that. So I would say when we think about visualization and visual analytics, we should think more conceptually about techniques that are useful. And then, yes, there are tools that are better or worse. I definitely think, Tableau, for example, is a perfectly good solution. But maybe in 2 years, there's a different, better solution. So I wouldn't equate kind of a technique like visual analytics with tools. I would say there's different tools that can be used. And over time, those tools might change.
Another question, can we consider Gmail text recommendations as text analytics when it comes to deep learning?
Yes, so Gmail and lots of other tools will suggest things. So Microsoft does the same thing. They'll correct spelling, but they'll also make suggestions about finishing the word for you, or even finishing a full sentence. So that is definitely predictive analytics. It's making a small little prediction that you can agree with or not agree with. And if you think about it, if it's always wrong, it's going to be really irritating. If it's always right, it's really helpful. And so that is definitely text analytics using deep learning. That's a good example.
Are you able to share more about your work experience? You talked about it a little bit.
Yeah, so so yeah, I didn't really talk about myself and my background, so I'm more than happy to do that for maybe a minute or two without boring everybody else. So I came to Syracuse about 7 years ago. Before that, I worked for mainly large banks. So I worked in doing predictive analytics. One of the big projects I had, I was in charge of credit card authorization. So anytime you use a credit card, you kind of wait just like a second, and then it says approved. So I was in charge of saying yes or no based on different rules. And so you build up predictions, and you would think it's very easy. And there's really 2 aspects to that. So I'll maybe talk about that one because everybody can kind of understand it. So there's, can you afford to make the charge? Can you afford to actually do it? That's actually pretty easy. Like, you have a credit limit. We have rules and ways to think about, can you pay even more than your credit limit and things like that? That's easy. The much harder part is fraud, because there's what we call bad actors, which is mobs in various parts of the world that are proactively trying to outsmart you so that they pretend that it's good, and then they do all these charges, and then the company's out all this money. So you're trying to figure out, basically, are you think you are who you say you are? And that can be a challenge, and you try to do various different techniques to build up patterns of what's acceptable and what's not acceptable. So as a very simple kind of a pattern that's bad is if you buy something in Syracuse, New York, in an on-present location, and then 10 minutes later you buy something in, I don't know, Miami, Florida, something's up, right? So that's an easy one. That's like very simple. But you can do things that just don't make sense from a typical buying pattern. Or you typically buy this type of thing for this amount, and now we see something very different. So you look for patterns and you make a prediction whether it's you or not. And so sometimes if you use credit cards, every once in a while, for example, when I use a credit card, I do something out of my normal and I get a text. Did you really do this transaction? It's like, yes, I really spend all this money, I'm sorry. And they say yes, and it's fine. But if I didn't say yes to that, they would have closed down my credit card until I talked to them and things like that. So that's an example of one of the things I did in my previous life.
We have a question from Wendy asking, does predictive analytics involve machine learning?
Yeah, so that's a great question. So I think there's lots of different phrases that I used and Raj used that there's not a clear, consistent definition. So machine learning, data science, predictive analytics are three, but there's others that kind of get used. Artificial intelligence, all have subtly different definitions, but those subtly different definitions are not consistent. So if you ask 4 data scientists, they actually might give you 4 different answers. So I think to keep it simple, I would say machine learning is the act of trying to make a prediction, trying to do predictive analytics. There's other ways you can do predictions besides machine learning, but that's one of the key ones that are used today. And so these different techniques, while subtly different at a high level, you can think of them all about trying to make predictions using data.
So there was a second part of the question they just asked, is it automatic?
Automatic. So I think we should think that nothing's automatic, that machine learning works because the machine learning algorithm is looking at lots of data that we've given it. And then based on that, it's going to make a prediction. It's going to learn about, here's blue marbles and red marbles, and how can we predict what's what? Or this blotch looks like cancer, and this blotch does not look like cancer. And over time, we correct it, and the machine learning algorithm learns. So it's not really automatic. It learns through looking at data, and typically through data that we kind of tell it correct or wrong, or looking at a whole bunch of different cats, and then eventually the machine learning algorithm can look at an image and say, that's a cat, because I've seen lots of images that are cats and lots that aren't. So it's not really automatic, but it can seem automatic to people that are using it.
So we have just about 5 minutes left with this presentation. So we actually have a great question from an iSchool alum. So they're working for a credit union currently building a data warehouse, and they ask, what's the scope of integrating predictive analytics with data warehouse in the future?
So data warehousing, I'm going to kind of simplify data warehousing to it's a technique that can be used to store lots of data, which is really important for predictive analytics and building machine learning algorithms, because we need lots of data for the machine learning algorithm to work well. So in many situations, having a data warehouse or some other repository for lots of data is the first step in building a data science or machine learning or predictive analytics, because without all the historical data, you can't build a model that's accurate. So it definitely makes sense to connect the two logically. And very often you first have the data and then you can build a predictive model. I guess we should ask if there's any questions in here too. You just came to listen.
We do have one more in the chat.
Sure.
So they're asking how data analytics applies to situations where back testing is not applicable. For example, in climate-related situations.
So that's a good question. So let me first explain what back testing is. So if you have lots of data, one way to see how good, I'll simplify what back testing is. One way to see how good your algorithm is, how good your machine learning algorithm is. If you have lots of data, you can use, I don't know, maybe 2/3 of the data to build up your model. So you kind of train your model, you build your model based on 2/3 of the data, but you hold off 1/3. And then you want to see how good the model was. And you pretend you just found all this data. Now you just didn't find it, but you held out 1/3, which data scientists call test data. So you test your model with data that you've previously collected, but the model doesn't know about, and you see how good it is. So there's a lot of what's kind of known as like testing and learning from that. So you train and then test the model, all on historical data. So that's a very traditional way to understand what's going on. But in lots of fields, and climate change is a good example, we don't have that much data to do back testing. And so you still try to do that. You can still have a model and you can kind of hold out some data and then see how it works. But there are other techniques that you can use to try to understand how the model is behaving. And sometimes, like in the Netflix example where it's being used in real time, you can see how it's being used in the future. So in climate change, oftentimes there's some prediction about the future. And then a few years down the road, you can kind of see if that's being held true or not.